Hi, my name is Caitlin Daly, and I'm a master's student studying statistics at McMaster University. This video will introduce you to my research on transference of pediatric reference intervals using hospital-based data. The first thing I am going to focus on is reference intervals. Let's consider the situation where a doctor is examining a patient that presents symptoms of several diseases. This doctor may opt to send the patient to a lab and have blood work done before he or she makes a diagnosis. When the results of the blood work are returned to the doctor, how does he or she interpret the results? This is where reference intervals comes in. Reference intervals outline the range of values within which a specified percentage of measurements from healthy individuals would fall. That is, they help clinicians know if a result is normal or not compared to the results of other healthy individuals that share the same demographic characteristics as the patient. What many people may not realize when they are getting their blood work done is the amount of work that goes on behind the scenes to ensure proper interpretation of the results. Once the data from healthy individuals is gathered, theoretical or empirical percentiles defining the reference intervals can be calculated using parametric or non-parametric methods. Current guidelines recommend defining the central 95% range of values by ranking percentiles, using a minimum of 120 healthy reference individuals. However, achieving the minimum sample size is not easy. The process of finding and collecting samples from healthy volunteers usually involves a lot of time and money. As a result, researchers often settle for a smaller sample size and use other statistical approaches to calculate reference intervals. Alternatively, researchers can calculate reference intervals using data from hospital databases. Hospital data can be viewed as a composition of healthy and unhealthy results. If the healthy proportion of these results can be extracted, then those healthy results can be used to calculate the reference intervals. In past literature, extracting healthy results to compute reference intervals has been done in one of two ways. The first is known as the Hoffman approach, where the cumulative frequencies of the hospital data are plotted and the linear proportion of the curve is taken as the healthy proportion of the results. The second is known as the mixture approach. A mixture distribution of two or more components is fitted to the hospital dataset. The identified healthy component is then used to calculate the reference intervals. Another alternative for researchers who are unable to collect enough healthy samples is a procedure called transference. Instead of producing its own reference intervals, a laboratory may choose to use reference intervals established by another laboratory. If a laboratory's analytical system and reference population are comparable to the laboratory that published the reference intervals of interest, then the laboratory may transfer the reference intervals to its own. However, the acceptability of the transference of a reference interval must be validated by the receiving laboratory for it to be considered transferable. To validate the reference intervals, the Clinical and Laboratory Standards Institute requires the receiving laboratory to collect samples from 20 healthy reference individuals. At least 90% of these healthy individuals' results must fall within the reference interval for it to be transferable. However, as I've mentioned before, obtaining any number of healthy reference individuals is not easy, and this is especially true for pediatric populations. As you can imagine, it is quite difficult to obtain blood samples from children. So, is there a way for a lab to perform transference without collecting samples from healthy individuals? We have already seen researchers producing reference intervals using hospital-based data. Can these same techniques be used to validate the transference of reference intervals? What my colleagues and I have been working on is a method that makes use of the mixture approach in the transference of reference intervals. This is what I would like to introduce in my presentation at the SSC Student Conference, along with a simulation study that illustrates the performance of our method in comparison to traditional transference. I would like to acknowledge my colleagues for their tremendous help in this project. And here are some references to accompany my video abstract. Thank you for taking the time to listen to a brief introduction of my research. I hope you found it interesting.